Okay. What we have been doing all this unit, Pythagorean theorem, special right triangles, trig, all of that culminates in this lesson, which I love because it ties everything together. You tend to not like it because it ties everything together. What?
We do proofs?
No. No proofs. But our goal today is going to be what we call solving right triangles. And we'll talk in just a moment about what it means to solve right triangles. Before we get to that, though, there's one last piece of information that we need to look at. Some of you asked last time what that -1 exponent is. If you look at your calculator, usually the second sine or the second cosine are those, what looks like to you as an exponent of -1. That is what we call the inverse. Okay? So we would say that's the inverse sine or inverse cosine or inverse tangent. Okay? What we use our inverse trig for is to find angle measures. So we need to be sure that we understand the trig ratios are for side lengths. The inverse trig is for angle measures. Okay? If we know the sine, cosine, or tangent values of an acute angle of a right triangle, we can use those inverse trig functions to find the measures of the angles. What we'll look at first is just some general rules, and then we'll look at specific examples of how that works. So, with that being said, let's say you know that the sine of angle A equals some value. That value could be a fraction, it could be a decimal, it could be whatever, okay? The sine of angle A equals some value. If you take the inverse sine of that value, that will give you the measure of angle A. And like I said, we will look at a specific example so you can see exactly how this works. But we're taking the inverse sine of that value, and it will give you the measure of the angle. Very similar thing for cosine. If the cosine of angle A is equal to some value y, if you take the inverse cosine of that value, it will give you the measure of the angle. And again, similar type of thing for tangent. If the tangent of angle A is equal to some value z, again, that could be a fraction there, that could be a decimal, it doesn't matter. If you take the inverse tangent of that value, it will give you the measure of the angle. All right, if you don't have your calculators out, which you should from your little quiz, but have those handy because we need those calculators to calculate these inverse trig functions. First example, it says angle A is an acute angle. Use a calculator to approximate the measures of angle A, round to 1 decimal place. Round to 1 decimal place. So we're following this general idea. Think of that 0.42 as being that value of x in the general example. So what we'll say is the inverse sine of that value is equal to the measure of the angle. It's essentially what we wrote 3 times up here, except for instead of a general variable x, y, or z, we have an actual value. And then here's where your calculators come into play. Again, for most of you, you have to hit your second button, and then the sign button will give you the inverse sign. So second sign for inverse sign, and then 0.42, hit enter. Be sure that you are getting that the measure of angle A is about 24.8 degrees. Give me a thumbs up if you're getting that on your calculators. Okay. That being said, let's do one more example, then I'll let you do the last 2 on your own. So this time we have cosine, so we are taking the inverse cosine of 0.68. That will give us the measure of angle A. So do it on your calculator. Let's be comfortable using our calculators.
So what do we do the second thing and what?
Cosine in this case.
Okay.
And then of 0.68. Taylor, what are you getting?
47.1.
We should be getting 47.1 degrees.
Oh yeah, it'd be 0.2.
Would it be
5
0.2?
after the 1, yeah.
Okay, great. All right, take just a moment. Look at the next 2 on your own. Even though that value is a fraction, you can still enter that fraction on your calculator. So, inverse sine, just type 5 divided by 12, hit enter. You would enter it the same way you would a decimal. If we take the inverse sine of 5 over 12, that will give us the measure of angle A. Jackson, what did you get for that one? 24.6. Good, 24.6 degrees. And then finally, the last example uses tangent, so make sure you are taking the inverse tangent, this time of 13 over 12. The measure of angle A on this one, Colton, what did you get? 47.3. 47.3, good. Okay. So what we have here is I always think of this lesson as a big toolbox. This is another tool in our right triangle toolbox, okay, that we can pull out if we need it. Back to what we started class with, which is looking at solving a right triangle. Let's think about what every right triangle has. Nolan, what's something every right triangle has? Okay, every right triangle has one right angle. What's something else that every right triangle has? Taylor?
2 acute angles.
Okay, we have 2 acute angles. Artem, what is something else every right triangle has? Okay, we have 1 hypotenuse. And what else does every right triangle have? Emily? 2 legs. In total, every right triangle has 6 parts. Would you agree? We have 3 angles and 3 sides. 6 parts total. What it means to solve a right triangle. This is where we are going to determine the measures of all 6 parts. We're going to find the measures of all 6 parts. But to be honest with you, your job will only be to find 3 parts because you have to be given some information to work with to find the others. I mentioned kind of a toolbox idea. So let's talk about all of the things that we've discussed this unit that would be in our toolbox. What are some tools that we have to find either side lengths or angle measures of a right triangle? Pythagorean theorem. Something else. Side measures or angle measures? Carrie? Okay. We can, like last class, we can use our trig ratios to find side lengths. Scott, or Steve, where did Scott even come from? I don't even have a Scott in class, sorry. Steve. Okay, we have our special right triangle. These are our tools to find side lengths. What about angle measures? We haven't talked about any angle measures yet. Inverse trig. And the one that you always forget about because it's the easiest one. What else do you know about angles of a triangle? Yeah, the fact that they sum to 180 is another tool that will help us. So the inverse trig and the fact that the angles sum to 180 are the tools for finding angle measures. Let's look at the first example. Solve the right triangle. It says to round all decimals to the nearest tenth, so keep that in mind. Now, what I typically start with is finding the third part of what you already have 2 of. I don't know if that makes sense, but what do you already have 2 of?
The side lengths.
Side lengths. So what I always start with is because I have 2 side lengths, I'm going to start by finding the third. That's typically the easiest way to approach this. So if I'm given 2 side lengths, how can I find the third? Pythagorean theorem is probably your best bet. That's not to say that if you love trig, you can use trig. Okay? Most people, if they're given 2 side lengths, will use Pythagorean theorem. But again, if you love trig, then use trig. It does not even matter. So we're going to use Pythagorean theorem to find the value of c, which is the hypotenuse. So 3 squared plus 2 squared equals the c squared. And we are rounding all decimals to 1 place. So you can go ahead and grab your calculators and take the square root of that 13. And what do we get? 3.6. And then what I do is this. As soon as you find a missing side length or angle measure, put it in your picture. So take out that variable c and put in your 3.6. As soon as you find another measure, put it in your picture. a right angle. So our next goal is to find the measure of one of the acute angles. It's up to you. Do you want to do A or B first? I heard A. All right, so let's find, it doesn't matter. If you really want to do B first, then do B first. Let's find the measure of angle A. Remember, back to your toolbox. We have two tools for finding angle measures. One of them is the fact that all three sum to 180. Can I use that here? No. So what's my only other option? The inverse trig. All right, so here we go. Well, now the next question is, what trig function do I use? Why, Maddie? Why any of them? Because you have all three side lengths. So it does not matter which trig function you use. Maddie, which one do you want to use? Maddie wants to use tangent. So we will say tangent of angle A is equal to, this goes back to last class, tangent of angle A, that is the opposite side, which is 3, over the adjacent side, which is 2. So we have our trig ratio set up. Now we can apply the inverse. So the inverse tangent of 3/2 is going to give us the measure of that angle.
Oh, you don't even have to you don't have to simplify 3/2.
Nope. You can put 3/2 right in your calculator. So when we take the inverse tangent of 3/2, what is the measure of our angle?
56.3.
56.3, again rounding to the 10th. Very good. All right, so again, anytime you find a measure, put it in your picture. So I'm going to take that 56.3 and I'm going to write it in for angle A. All right, guys, we're getting there. We have one last thing to find, and that is the measure of angle B. If I know 2 angle measures, how can we find the third?
Adding them and then subtracting them from the 180.
You can add up your 90 and your 56.3, take it from 180. Again, if you are a trig lover and you want to use inverse trig again, go for it. But most of us might just take 180 and subtract the 90 and the 56.3 to get the measure of the third angle. For those of you that are actually staying with me today, let's jump over to the next example. So again, whatever you're given 2 of, start by finding the third. So in the first example, we were given 2 side lengths, so we found the third side length first. But this time, we're given 2 angle measures. So let's find the third angle measure first. How can we find the third angle measure given 2 of them? Taylor?
90 plus 25, and then 180 minus that number.
Exactly. So if you know 2 angle measures, we can take, for the measure of angle G, we can take 180 minus the 90-degree angle minus the 25-degree angle to get, what is that? 65. Thank you. Okay, so the measure of angle G, again, we took 90 and 25 from 180. That gives us that the measure of angle G is 65. I'm going to plug that into my picture. So I have all 3 angle measures, and now we need to do some work on the side lengths. Well, this is actually just back to what we did last time. If I only have one side length, I cannot use Pythagorean theorem. Hopefully we understand that. So what we have to use right now is what? What? Trig. All right, it's up to you guys. Do you want to find G or H first?
H.
All right, let's find H first. The other question is, do you want to use the 25-degree angle or the 65-degree angle to find h? You have a lot of choices here. There's not just one straight way to do it. You can pick. You want to use the 25-degree angle? Okay, sure. So we're going to find that side length h by using the 25-degree angle. Which trig function do we have to use?
Sine.
Why sine?
Because it gives you the opposite hypotenuse.
Because we know the hypotenuse, so we need to use that one if we're looking for h. That's the opposite. Good. So we will say sine of the 25-degree angle is equal to the opposite side over the hypotenuse. Again, this is what we did last class. Set it up as a proportion, cross multiply. And then calculate in your calculator from there. What? Not what I'm getting.
I did it different.
5.49.
Yeah, I should have about 5.5 rounded to the 10th. So I'm going to take that 5.5. I can fill it in my picture. Then the last thing that we need is to find the value of g. Again, you guys have options. If you're a trig lover and you want to use trig again to find that side length, then fine. But now that we have two side lengths, what else could we use at this point? You could also use Pythagorean theorem. It is completely up to you. There's really not one way that's better than the other. Okay? I am going to use Pythagorean theorem. So I will say that g squared plus 5.5 squared equals the hypotenuse squared, which is 13. And let's see, I have g squared, 5.5 squared is 30.25 equals 169. Subtract your 30.25 and take the square root.